Question 10b. The diagram shows a farmhouse, F, that is located 250 metres from a straight section of road. The road begins at the bus depot, D, which is situated 2,000 metres from the front gate, G, of the farmhouse. The school bus leaves the depot at 8 a.m. and travels along the road at a speed of 15 metres per second. Claire lives in the farmhouse and she can run across the open paddock between the house and the road at a speed of 4 metres per second. The bus will stop for Claire anywhere on the road but will not wait for her. Assume that Claire catches the bus at the point P on the road where angle GFP equals theta. Part 1. Find two expressions in terms of theta. One expression for the time taken for the bus to travel from D to P, and the other expression for the time taken by Claire to run from F to P. In right-angle triangle FGP, side GP is the short side opposite angle theta, side FP is the hypotenuse, and side FG is the short side adjacent to angle theta, which is equal to 250 meters. So applying regular right-angle trigonometry, the length of side GP is equal to 250 tan theta, and the length of side FP is equal to 250 divided by cos theta. Now recall that time is equal to distance divided by speed. So Claire's time, TC, is equal to 250 divided by cos theta, which represents the distance that Claire has to run from the farmhouse to point P, divided by 4, which is her speed, which is 4 meters per second. And that equals 62.5 divided by cos theta. And TB, which is the travel time of the bus, is 2,000 plus 250 tan theta. So 2,000 is the distance between the depot and the gate of the farmhouse, plus the extra distance from the gate to point P. So that gives 2,000 plus 250 tan theta in brackets divided by the speed of the bus, which is 15 meters per second. And that simplifies to 400 over 3 plus 50 over 3 times tan theta. Part 2. What is the latest time that Claire can leave home in order to catch the bus? The strategy is to maximize the time difference between the bus's time and Claire's time, assuming the bus and Claire arrive at point P at exactly the same time. Now the time difference represents how long Claire can wait after the bus has left the depot before Claire needs to leave the farmhouse to arrive at point P. Let T equal TB minus TC, which equals 400 over 3 plus 50 over 3 times tan theta minus 62.5 over cos theta. Now we need to differentiate T with respect to theta, but before we do that, we need to express the right-hand side using index form. So T is equal to 400 over 3 plus 50 over 3 times tan theta minus 62.5 times cos theta in brackets to the power of negative 1. Now applying the chain rule, we have dt d theta is equal to 50 over 3 times sec squared theta plus 62.5 times cos theta to the power of negative 2 times negative sine theta, which represents the derivative of the inner function here, cos theta. And that equals 50 over 3 times sec squared theta minus 62.5 times sec squared theta times sine theta. And factorising out sec squared theta from these two terms, we get dt d theta is equal to sec squared theta outside of 50 over 3 minus 62.5 times sine theta in brackets. Now we're going to let dt d theta equals 0. So we have sec squared theta outside of 50 over 3 minus 62.5 sine theta in brackets equals 0. Now note that sec squared theta is greater than 0. Hence, 50 over 3 minus 62.5 times sine theta equals 0, and this will have a solution. So solving this for theta, we get 62.5 times sine theta is equal to 50 over 3. Dividing both sides of this equation by 62.5, we get sine theta is equal to 4 over 15. And taking inverse sine of both sides, we get theta is equal to 0.26993 and so on. The next step is to determine the nature of the stationary point at theta equals 0.26993. So I'm going to use the first derivative and a table of values where the first row represents two values of theta around the stationary point of 0.26993, and the second row is the value of the gradient at the two values of theta around 0.26993. So I've chosen theta equals 0.2 and 0.3 to test around this stationary point. And when theta is equal to 0.2, using dt d theta, I get dt d theta is equal to 4.4, which is a positive gradient. And when theta is equal to 0.3, I get negative 1.98, which is a negative gradient. So theta equals 0.26993 represents a maximum value. Now from the equation with the asterisk, which is this one here, and substituting that value of theta we just found, we get t is equal to 400 over 3 plus 50 over 3 times tan of 0.26993 minus 62.5 over cos of 0.26993, and that equals 73.096531 seconds after 8 a.m. Therefore, the latest time Claire can leave is 8:01 and 13 seconds a.m. or 1 minute 13 seconds after 8 a.m.